Marginals. Marginals are used to approximate the revenue, cost, or profit of one more item at a particular production level. So for example, marginal cost, the derivative of the cost function at a production level of X items, the derivative, the marginal cost, is approximately the cost it would need to make the next item. So for example, the marginal cost at a production level of 20 items is approximately cost of 21 items minus the cost of 20 items. So this is approximately the cost to make one more item when we're producing 20 items. Similarly for marginal revenue, our marginal revenue, R prime, would be the additional revenue of selling one more item when we're producing 20. P prime at 20 would be the additional approximate extra profit that we would make from producing and selling one more item at a production level of 20. So again, it's an approximate because we're kind of using a little bit of that linearity idea of a function at a particular level, and that the derivative, which is an instantaneous rate of change, is approximately the average rate of change at that production level. So we can actually calculate the cost of one more item, or we can take the derivative and then calculate the approximate cost of one more item at lots of different values. So let's take a look at an example. Marginal cost. Suppose the monthly cost in dollars of producing X day packs or backpacks, whatever you want to call them, is given by that cost function. And currently 25 packs are produced monthly. What is the current monthly cost? So part A, the current monthly cost is C of 25. And so if we break out our calculators and calculate that up, I'll let you pause and calculate that and make sure we get the same answer. Okay. So if we plug this into our calculator, we discover that it would be approximately $1,234.38 to produce 25 day packs. Part B says what would be the additional cost of increasing production to 26 day packs monthly. So this is the additional cost of making 26. So that would be cost at 26 minus the cost at 25. And if we plug that into our calculators, the cost of 26 is $1,258.90 minus $1,234.38, which is 1258.9 minus 1234.38. It would be $24.52 to up my production from 25 to 26 day packs. Now part C says what is the marginal cost when X is 25? So it's basically saying when I'm at a production level of 25, the marginal cost should be approximately that $24.52. So first things first, we need the derivative. So that derivative would be 0.003x squared plus 0.14x plus 19. And then we would need to figure out what is C prime at 25, the derivative at 25. And if we plug that into our calculators, we would end up with $24.38 if we round to 2 decimal places, so not far off. Again, this isn't the exact cost, we're approximating. We're using that idea that the derivative, which is a linear, it's the slope of the tangent line, so that line, and it's similar to the slope of the graph of the function, so the cost function. Now, in part D, it says use the marginal cost to estimate the difference in cost between producing 25 and 27 day packs per month. So in this problem, we're going to use the cost of 25 day packs plus 2 times the marginal cost at 25. Because from 25 to 26 is approximately 24.38, and we're going to, since it's close by, from 26 to 27 should be similar cost, additional cost. That's what we're going to calculate this up to be. So the cost at 25 is 1234.38 plus 2 times the $24.38, which is actually, oops, sorry, I've gotten a little ahead of myself. This is actually the answer to part E. Ah. Which is approximately the cost of 27. So this answer, this part here, is actually the answer to part D, which would be the additional cost. So that's 2 times the 24.38 is $48.76. So it would be approximately another $48.76 per month to go from 25 to 27 day packs. And then if we add that to the cost of making 25, then that would give us the answer to part E, is where we would predict that it would be about $1,283.14 to make that one. All right, let's go further. This time marginal revenue. We've got Pierce Manufacturing, that's their daily revenue, and they currently sell 70 lawn chairs. And what is the current daily revenue? That is part A. So the current daily revenue is R of 70. And then part B will want to know what is the increase in revenue if we increased to 73. So we'll have to calculate that up. Part C, marginal revenue, is we'll have to calculate the derivative at 70. And then part C, we'll use that to estimate R of 71, R of 72, and R of 73. So right now, let's go ahead and you can use your calculators to calculate up A and B. And I'll give you the derivative that you'll use for part C and calculate that one up as well. And we'll come back and compare our notes. So the derivative would be that. Okay, so go ahead and break out your calculators, check those out, calculate them up, and then come back and compare. So go ahead and pause. All right, so after using our calculators, the revenue from making 70 lawn chairs and selling them is $1,799. Then the revenue would increase $235.88 by calculating up what the revenue would be at 73 minus the revenue at 70. That difference is $235.88. And then the marginal revenue at a production level of 70 lawn chairs is $75.40. And we're going to use that to estimate R1, R72, and R73. Well, R71 would be approximately R70 plus R prime at 70. So that would be $17.99 plus $75.40, which would be $1,874.40. Yep. And R of 72 would be approximately the revenue at 70 plus 2 of the marginals. So 2 marginal 75 would be $150.80. So $17.99 plus that would be $19.49.80. And then R of 73 would be approximately R of 70 plus 3 times plus 226.2 plus 1799 is 20, 25, 20. Okay, and notice each of these times when I calculated up, for example, R of 72, I could have taken the result 1874.40 and added 75.40 to that, and then similarly. But I wanted to show each one of those because if you were asked for just R of 73 without calculating R of 71 and 72, I wanted to show you how that would work and what that would look like. Okay, so remember, marginals are the approximate difference between production level and producing one more, whether it be revenue, cost, or profits. And again, it's approximation because we're using the fact that the derivative is a rate of change, instantaneous rate of change, that will approximate the rate of change of the function when we go from production level of, let's say, 70 to 71 or 72 or 73.